All right, so for the second part of our lesson today, we're going to focus on graphing of the rational function. Our steps are exactly the same, with the exception of now we know how to handle asymptotes that are not horizontal. So this would be the only step that has been modified. Everything else will be the same as last unit. So just to walk through our steps here, we determine the holes if they exist. And remember, holes occur when you have a repeated factor in the numerator and denominator. So if you can reduce your function, that produces a hole. Holes are going to be a coordinate point, an ordered pair that you would have to include on your graph using an open circle. Our vertical asymptotes, those are going to occur when you set your denominator equal to 0. So after you've reduced the holes, reduced your polynomial, reduced your rational, you need to set your denominator equal to 0, and that will identify your vertical asymptotes. Vertical asymptotes are going to be written as x equal, and those are just going to be vertical lines that we'll draw in with a dotted line. X-intercepts occur when your numerator is set equal to 0, because this is where your y is equal to 0. Our denominator is not going to have any play in our x-intercepts, so we just focus on the numerator. And we also need to determine our y-intercept, and that's going to be where x is equal to 0. So we have a coordinate point here, x is 0. We need to go find this y value. And revisiting number 3, we could write this out. We need to find x where y is equal to 0. Step 5, this is where we determine whether or not we have a horizontal or if we have a slant asymptote, and that will be by looking at that degree of our numerator and denominator. And then we complete our graph by using our knowledge of asymptotes, how they behave. We can use sign chart test, or we can plot some points. We'll probably be using the latter. So let's take a look at our first example here. So for example 3, let's start by going after some of those required fields. So we first need to identify any holes, and we see that there are no common factors, so there are none for this example. Now we can go after our vertical asymptotes. We have two factors in our denominator. That's going to be when x minus 1 equals 0 and when x plus 2 equals 0. So we have two vertical asymptotes at 1 and at negative 2. Horizontal asymptote. So we can use our little Boston mnemonic. The degree of my numerator is 1. The degree of my denominator is 2. So the bottom is bigger. So that tells me that we have this scenario. Our horizontal is y equals 0. All right, so let's go after our x-intercepts. X-intercept is where y is equal to 0, or in other words, where your numerator is equal to 0. So that's going to occur when x is equal to negative 1. So that produces the coordinate point negative 1, 0. And then our last one is our y-intercept. This is going to be where x is equal to 0. Put in 0 for x. We get 0 plus 1 over 0 minus 1, 0 plus 2. That's 1 over negative 2. So we end up with the point 0, negative 1/2. So we're going to need a piece of graph paper where you can sketch in your notes. So let's take this. I've already just copied my problem down. And what I want to do is create ourselves a little t-chart of the values that I have. We know that we're going to have vertical asymptotes at 1 and negative 2. So let's go ahead. At negative 2, we know we're going to have an error there that produces our vertical asymptote. And then we said our second one is at 1. We know that will produce an error. That's another vertical asymptote. At 0, we have a half, negative 1/2. And at negative 1, we have 0. So we know that there's that asymptote here, asymptote here. So we're going to need some values around there. So we're probably going to have to find just a few more points in here. Maybe find some values inside of here, and maybe just to see what's going on the other side of that other vertical asymptote. So why don't we create a graph here? Let's see. So here is let's put in our asymptotes. So at -2, and at 1, and I know my graph is a little bit off here, but you have to bear with me. We have points at -1, 0, and at 0 we have -0.5. And then we also have our horizontal asymptote at 0, so we don't want to forget that. So we have a horizontal asymptote coming this way. You'll notice that I do have an x-intercept, and that's intersecting our horizontal asymptote, and sometimes that will occur. So horizontal asymptotes can be crossed, but vertical ones will not. All right, so we need to know what's going on. So we need to know, is my graph, is it going to have data in the upper positive quadrant, or is it going to be in the negative quadrant? So we need to kind of figure out what's going on this side over here. So one thing that you can do is you can just plug in a value. We can plug in a value over here to see, is it positive or negative. The other thing that you could do is use your calculators. We have our TI-36X Pro. If you would like to grab that, you can pause the video at this point. All right, so once you have your calculator on, I want you to go to Table and Edit Function, hit your fraction bar, and put in x plus 1 in the numerator. And in the denominator, put in x minus 1, put that in parentheses, and then an x plus 2 in parentheses, and that should also be in the denominator. Once you get that entered in, just hit enter. And if you just want a running list of numbers, you can say it doesn't matter where you start. Maybe you start at 0 if you like, and you can do auto. Or if you want to select a specific x value, which is what I'm going to choose, because I specifically want to pick those that are in that yellow region, I'm going to choose x with a question mark, so I can choose the value of x and hit calculate. All right, so let's pick some values. All right, so I would like, let's see what's going on at -3. So I type in -3 and I get a -1/2. So at -3, I'm at a -1/2. Now, I know that horizontal asymptotes can cross, so if I want to, more than likely it won't cross again, but they could. So let's just pick another value. So we've got -3, 4, 5, 6, 7, 8, 9, 10. Let me go over here to -10. And we'll see that that's still on the negative side, but super close to that x-axis. So my inkling is that this graph is doing something like this. It's going to hover around that vertical asymptote. If you wanted to pick a value in between the -2 and -3, you could, and see that you will find that your data is indeed in this negative region here. So we've got this part. Let's go over to the right hand side. So we want to see, am I going to have data up here, or is my data going to be down here? So let's pick another value. So we have 1, 2, so maybe I'll choose 2. So using my calculator, and I get 3/4. So I'm somewhere right about here. And then again, I could pick 10 if you wish. So we've got 2, 3, 4, 5, 6, 7, 8, 9, 10. So I type in 10 and I get a value that is super close to that x-axis. So it kind of looks like it's got the same kind of behavior, just going from a different direction. It's getting super close, like so. So now we have these two areas figured out. So now let's see if we can figure out the middle part. All right, so in the middle, we know we've got something like this going on. So my feeling is that it's probably going to trend downward, and that's because we already know it's not going to cross the x-axis again. So that has to go down. And I only had one multiplicity here at my 0. But if we wanted to test, we can definitely test a value. If you want to pick a point that's in between here, so maybe negative 1.5. We put that in using our calculator, negative 1.5, and we get a positive value. So we're correct, so that my graph is looking something like this. All right, and then over here, just to write down my notes, we have that. If you want to check your graph, feel free to hop over to Desmos. We can do that here. I'm using an iPad to do this recording. I can go over to Desmos, and we can type in our function x plus 1. And I'm going to put in x minus 1 and x plus 2. And we can see that we have a very similar graph. Good job. All right.